Okay, so you may have seen Euler's identity, which is e to the I pi plus 1 equals 0. And the reason that this is significant is the fact that it uses so many fundamental building blocks of maths, like Euler's number, e, which is like an irrational number like 2.718, so on. I, an imaginary constant, square root minus 1. Pi, which is another irrational thing, which, is obviously due to this, the ratio of the circumference to the diameter of a circle, and 1, which is a very, how would 1 not be important? Like, you get 1 of something, and then 0, which is another thing where it's like, oh, is 0 a number? So also very, like, I guess, controversial thing, but it's a very important thing in maths. All of these are important different constants and things in maths. But how does this work? How can, like some 2.7182881, blah, 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 raised to the power of I of, 3.14159, etc., plus 1 equals 0. How does this even happen? Okay, well, it's actually simple. It's because e to the I pi is actually the same as our form r e to the I theta, where, as you can see, r equals 1, theta equals pi. When does this occur? Okay, so we draw an argon diagram with an imaginary axis and a real axis. We want somewhere where there's a 1, because our modulus is 1, so it's somewhere of one of these points, and our angle is pi, so it's going to be across here like this. So this is pi. So that means that it equals minus 1. So we can clearly see z equals minus 1, which means that e to the I pi equals minus 1, and minus 1 plus 1 equals 0. So this is why Euler's identity works, okay? That's how that weird rational number, it's quite simple just because of imaginary numbers, how they work. That's why that works. However, technically, there is actually more to it, because if we do the same thing we just saw, well, this is our, z equals the minus 1 because of that, however. This is pi. However, we can go, because it's in polar form, we can go around in a circle. So it should be plus 2 pi k for any real integer k. Which means that realistically, it should actually be written as e of I of pi plus 2 pi k plus 1 equals 0. This is actually the proper Euler's identity, which is very interesting.